Well, during these early morning hours of today, that's because it's midnight and it's the start of the 15th of August now, we're going to solve a different fashioned way of solving this same equation I just did in this previous page here. So what I did was just factor it in terms of like trigonometric sines and cosines, but in a different fashion. If sines and cosines confuse you, you can use algebraic x's and y's to solve this. But I'm not going to use x because you got to be careful. So I am going to approach this by using u substitution. So say that let u equal the sine of x, right? So that u squared is equal to sine squared of x, right? So then if I write this in terms of u's, I get 2u squared plus 3u plus 1 equals 0. And then I just solve this. I mean, I see that this is a factorable polynomial, quadratic trinomial. So you use a times c, which gives you 2. Factor it out, you get 1 and 2. And then I just split this up. 2u squared plus 2u plus u plus 1 equals 0. And I can take a 2u out of a u squared. And I get u plus 1 plus u plus 1 all equal to 0. And then I pull out my factors, which is 2u plus 1 times u plus 1 equals 0. And I use zero product property just to solve for u. So let's see, we have 2u is a negative 1. And u is a negative 1. So that makes u a negative 1/2. Because we divide 2 by both sides. But this does not answer the question. So let sine of x equal a negative 1/2. And let sine of x equal a negative 1. But here's a catch here. Sine of x equaling negative 1, I just found out is an extraneous solution to this problem here. And x is actually not equal to 3 pi over 4. Right? So this is out of the question. We're only looking for the solutions where sine of x is a negative 1/2. So I create my unit circle. And remember this A, S, T, C thing. So if sine is negative, it's not in the A and S. In the T, we have 1, 2, 3, 4, 5, 6, 7. So I know 7 pi over 6 is one of our solutions. And then we have 7, 8, 9, 10, 11, somewhere around here. And x is also 11 pi over 6. Now, those are only on the given interval from 0 to 2 pi, but we're not giving an interval. So we have plus 2 pi k and plus 2 pi k. And ladies and gentlemen, I also found the solutions in degrees, if it asks in degrees. So x in degrees is 210 plus 360k and 330 plus 360k. And one thing I'd like to tell you about, let me tell you my pet peeve before I close this video. If you're solving sine of x equal to a negative 1/2, and you take the inverse sine of both sides, that's a pet peeve of mine when you're solving trig equations. Inverse sine of a negative 1/2. And if you try sticking that into the calculator, oh, horrible job at my parentheses there. But if you try sticking that into the calculator, you're likely going to get a negative pi over 6. And that solution is just off for support. You see that? I mean, sine of x is negative 1/2, so I take inverse sine of both sides, and I get, I mean, negative pi over 6, if this was in the interval of 0 to 2 pi, this is out of domain. See? So say that x is from 0 to 2 pi. See? X cannot be negative pi over 6. See that? Out of domain. And ladies and gentlemen, that solves this.